Hello everyone, my name is Tamar Hamid. I'm the chair for UMBC at IEEE. In this week's GBM, I'm going to be covering the M5Paper ESP32 dev kit. It's a lot of words, a lot of numbers, but I'll explain what what that means. So, starting off, I want to thank M5Stack for sending us their M5Paper like dev kit itself. I found it online, messaged them saying, "Hey, we're a student branch. This seems something cool. It seems like something cool to share," and they just sent it to us without asking like any questions, and they're kind of awesome for doing that. So I just wanted to send a thank you to them for giving us the tech. But a little bit of review. So last week I covered the ESP32 dev module in detail. I'm going to review that. The ESP32 is just like a low-cost microcontroller chip developed by Expressive Systems. It's like an Arduino, but souped up to be to have like a lot more functionality. Usually it has a 62-bit processor, either single or dual, but most configurations have a dual processor on there. Dual core processor on there, and then it also contains both Bluetooth Low Energy, Wi-Fi, can be programmed using Arduino IDE, as well as MicroPython. I'll cover MicroPython in a separate GBM, but it's very low cost, it's very simple to use, and it's very powerful at that. And unsurprisingly, M5Stack, which is the company that made this, took this microcontroller board and put it in one of their projects. And this project is very much like open. I wouldn't necessarily open source, but the components and everything they use are on their website. This M5Paper is essentially an ESP32 module where they've included a bunch of extra onboard peripherals. The peripherals they've included is a e-ink screen with 16 levels of different, like I guess grading, then a 16 megabytes of flash, battery, SD card slot, 3 function button, a reset button, 3 expansion ports, and a USB-C for charging. I'm really happy with USB-C. Everything in the world needs to be USB-C, and it's good to not have to carry on an extra cable just to program this thing. But it works very well. It like I said, it's at the end of the day just a simple Arduino type microcontroller with a lot of extra functionality that you can add, and it programs exactly like you would on Arduino. So you can write any code on there and it'll run it. This is a couple of other pictures. As I said, they keep the technology very open. So here they have a list of different parts of it and see what it does. These right here are a couple of expansion ports that you can add, and you can actually access these pins in program. So if you want to, I don't know, hook up a motor or something, this is what you do it. And here you can see this would be 5 volts, data, 2 data pins, and a ground. So it's very much expandable. So without that, like after that intro, it is, as I said, just an ESP32 board, and it takes good advantage of the Arduino IDE, which, as I previously said, is the secret sauce of Arduino. It extracts away all the little nitty-gritty things you have to deal with when you're writing code for microcontrollers or for hardware, and this leverages that to make even accessing the onboard peripherals, the screen, the different buttons and such, really easy. And there's amazing documentation for it as well. I'll go into detail as to how to access the different things next couple slides. So initially, since this is a different piece of technology, you need to include drivers. If you buy like a recent new Arduino, sometimes they have microcontrollers on there that need a separate driver, so this isn't anything new. You can go and download the drivers from this website. It also includes a couple of extra instructions to set it up, but I'll be echoing those instructions here. To set it up, really after you install the drivers, it's just the Arduino IDE you're setting up. So what you first want to do is add the board manager. This will download all of the necessary files you need to work with an ESP32, and more specifically with the M5Paper. This will have all the component files, all of the extra setup stuff you need when working with hardware like this. It's very easy to install. You just need to add these 2 URLs within your board manager, and you should be able to access it. One more thing. So occasionally, sometimes there's like glitches. This is developed hardware, and you can't ever get everything right perfectly. So when you're using Arduino, you need to go to your Arduino libraries, access this file, and comment out these two lines, and just copy and paste this line in there exactly. There was an issue with using the touchscreen. You can display stuff to the screen, but actually getting touch functionality out of there was causing a couple errors due to just how it was set up. So if you're using Arduino, follow these steps, or if you're using platform.io, which is another way to program these things, just edit these couple of lines of code, and that's good. You don't even have to compile them. The IDE itself takes care of all the compilation and everything. So let's work with the actual onboard stuff, the peripherals. The most notable part is going to be displaying to the screen. It's a e-ink screen, so it doesn't use much power. The only power it needs is when it's switching or changing something on the screen itself. And to work with that is they have this detailed documentation, but I'm going to give you the crash course of how to make it work. So it's going to work exactly like any other display. You would download a library for it in Arduino, be able to add simple shapes, and create a canvas, set the screen size, update new data. So this is kind of a design paradigm to any type of programming framework or anything that uses canvases and uses a screen like this, where you don't want to continually draw to the screen. You kind of just want it to update the screen when there's a change. So here you're going to be creating a canvas, setting everything up. Then none of this data or none of the new stuff is going to appear until you push to the canvas, update the canvas right here. That sort of saves power and makes it a little more functionable, so you don't have to worry about having a second per second think of what's going on, and just kind of having to worry about, hey, I want this data to be pushed after I actually give the update command. Otherwise, it's going to be displaying the old data. The code to do this is also pretty simple. You would include, this is the M5 library right here, includes everything you need to program the board. But you would have a canvas object. Everything's object oriented, so if you've gone through 202 or 201 even, now you should have like a basic idea of objects are. If you don't, read through the documentation, you should be fine. But it makes a canvas object. This is a bit of code that I included myself, but you want to do M5 begin. This will start up all the background libraries and all the different signals it needs. Set the rotation. This is in degrees, so I have it set the rotation to 0 degrees, and you'll see a picture of what this looks like. You can have it be vertical, landscape, any way you want. Initially clear it, create canvas, set text size, and just update the canvas every second. This is the Arduino delay function, which works on milliseconds, so 1,000 of these will equal 1 second. What this program is basically doing is this loop is going to run every second. It'll go through, update the string on screen to like increment the counter, and then push it, and also give it a serial for debugging. I included a little video showing how that works right here. I hope that comes through screen. There's no audio, but you see it's updating the screen. So the location for it is set by these. These are pixels, so 50 pixels by 50 pixels. It draws the edge of this number. Then every 1 second, it gives a canvas push, updates it on there. It doesn't go do a complete update. The downside to using e-ink is that it's slow. It's very, very power efficient, but it is it can be a bit slow to update. And if you view this closely, you'll see as it's changing throughout, there's a couple of shadows and artifacts left from the previous number there. That's just a side effect of using an e-ink screen, because you need to do a hard refresh for it to completely get away of all the different artifacts. Moving on to the buttons. So the side buttons, as shown here, you can kind of see it. This is a triple function button. You can push it up, down, or look left, right, up, down, and it'll have 3 functions. You can actually assign it those 3 functions. Let me get back to the There you go. So you can assign all those three functions to do their own little thing. Here, then there's no need to debounce. When you work with hardware and you're working with those physical push buttons, one of the things you run into is debouncing. Buttons are analog; they're just connecting a signal, and when you press something like something analog down like that, the little tension there is going to make the signal bounce for a little bit. So you'll have multiple ones and zeros going through it, which is going to kind of ruin your input. So a lot of times if you're dealing with an Arduino or another microcontroller, you'll have special code to kind of give it a little delay or to take those inputs in there to help get a clean 1 and a clean 0. You don't need to do that here. It's all abstracted away in their library. And not only it's a very thorough library too. So these three are the different button methods. So button L, button R, button P, left, right, push. And you can not only tell which one of these was pushed, but how long it was pushed for. So if you want to extend functionality of these even more, where if the left button is pushed for 2 seconds or 3 seconds, it does something different compared to if it's just a quick push. You can implement that as well. The code to do that is right here. This is just a setup function. Initially, I'm just drawing a string saying press the button. It's creating a canvas because we're again using the screen, setting up everything, and this is shown in the library. So begin, set rotation, clear, touchscreen. All this stuff was on the like the back screen, that screen slide. And then here in the loop is the actual push button code. So once you have it set up, you want to give it this M5.update method. What that'll do is it'll look at the state of all the buttons and say, hey, have any of these changed? If they've changed, I'll update and the M5 object. Otherwise, I'll just keep it as it is. So then you can, after you've done update, you can go through and say, hey, if button left has been pressed, clear the canvas, fill 0, print out left at pixel 5050. Otherwise, if the right button was pressed, print out right. If the push button was pressed, print out push, and then push that to canvas. And there's another video showing that functionality. So left and right and left again, but push button, yeah. I'm holding a camera with one hand and trying to control this with the other, so it's a little not as elegant as it should be, but it gets the job done. So we've learned those two basic things, and they're pretty powerful because they're basic fundamental things you want to do when you're learning any hardware. How to use a screen, how to use the buttons, how you can get input from them, and with that knowledge, let's try to actually make something. So the small project that I thought of with it was one of the things that I wanted to do in the project is to use a screen, to use the side buttons, to use Wi-Fi, because that is one of the big selling points of an ESP32 is the onboard Wi-Fi and Bluetooth. I also want to use an API, which I'll cover. I want to parse JSON, which I'll cover as well. And I want to be able to have it display multiple things. I don't want it to just be one static thing. I want to actually be able to change and add stuff to the screen based on command. So taking a small detour to APIs and JSON. If you watched last week's GBM, you've seen this already, but I still wanted to review it. An API is something that's not unique to the ESP32 or even to hardware. It just stands for Application Programming Interface, and it's just a connection between computers and server, or between computers, or even between computer programs. It's a way for your code to talk to other code and be able to use that other code in your own projects. Everything on the web uses this. Just go to any big social media service or just any big website, and it will have a little page dedicated to purely just to its API and the stuff you can do through it. I know Twitter specifically has a very nice API that's been ported over to all these different languages. And one of the things you can do with an API is submit a GET request. A GET request is a query for specific information. So if I hook this up to a database and say, hey, I want you to give me all information on, I don't know, a person, like on this person's name, that would be the GET request I'm sending, and what the database would send back is specific data related to that request. They're a lot easier in practice. Every API is going to have a special URL that you just send the request to, and it usually finds its way back. So the requested data is sent back, has to be sent back a specific way. The internet is built off of protocols, ways, standards that someone has set to make using it very easy. And one of those kind of protocols is JavaScript object notation. This is a JavaScript standard that's sort of been ported over to be used, it should be generally used. It's not really linked to JavaScript anymore. That's kind of just where it got its start, and the name stuck. The way it works is that it's built from key value pairs, very much like a dictionary or something in Python, where you have the object overall. Then you'll have these keys right here. So first name, last name, location, online followers, and then you'll have these values. So if I want to access the first name, I would do object first name, and that'll return Sammy. So not only will this handle text data, it'll also handle booleans, numbers, floats, whatever you need. But one thing about it is C++ is a strong type language. Yeah, you have types, you have integers, you have floats, so you should know what the JSON of a query is going to relatively look like. If you don't, then you can get like type conversion errors. So just keep that in mind. If you're using C++, then know what these key value types are. If you're using Python, it doesn't really matter. Python converts, or even JavaScript just converts for you. Arduino JSON. So as I said, we are using C++. C++ by default makes it a little difficult to parse JSON, since this essentially comes in as a giant block of text. And if you're switching between multiple APIs, you kind of have to write a text parser, change up the text parser a little bit for each one. So what the inventor of Arduino JSON did was they took all that, made it one library that you just import, and you can shove the JSON response in there, and it'll abstract away everything. The way this works is you just have a container that holds the JSON, then you have a deserializer, and that takes the string JSON data, tosses it into the object, and you can access it like you would any JSON object. You would do type, key name, variable name, and then object with key, and I'll return the value it's storing. It has amazing documentation online. One of the best I've seen, really. It even has this applet that tells you how much storage a JSON file is going to take, a JSON response is going to take up. Really good documentation. So the APIs I chose to use for this tiny little project is first one is Polygon.io. It gets stock data. It has a paid version and a free version. The free version only gives you stock data previously. It doesn't give you any live data at all. But the paid version gives you up to real time, up to the second data. For our purposes, the free one's perfectly fine. We're just going to get the last day's close, so and open close prices for any particular stock. Then I wanted to have something with weather, so this is where I included Open Weather Map that gets live weather data and lets you display it. This one's also paid, but they have a free version for it as well, less options to use, but it works well enough. This one's just for the fun of it. It's a random quote from Ron Swanson from Parks and Recs, completely free to use, and it's using Heroku, which as students, if you sign up for GitHub Student, you can have free access to Heroku. Just a tip. Random Jeopardy question, I wanted to include that on there as well. Again, this is a free API, no key needed, nothing super, no sign up or anything, and a random joke. Free API as well. All these APIs take up server space to run because you are sending a request to a server. The server has to process your request and send you back the response, and that takes cost and time and stuff. So it's not out of the ordinary that a API would be paid. These ones are, I don't know how they're making their money, probably through ads or something, but it's a premium API is not unheard of. So the project code. Initially, I'm going to include all my libraries, so the M5 library, Wi-Fi, HTTP client for the GET request, string, Arduino JSON. Just have those in there so you can access their functionality. They're all documented and all available with like a simple Google search. That you actually access the Wi-Fi. I covered this in more detail at last GBM. It's on our YouTube channel if you'll want to watch it later. But to access Wi-Fi, you need to save your Wi-Fi name and password. These are those JSON documents that I told you about previously, where each one of these corresponds to a particular API. Then I'm saving their JSON response in here so I can access it later. Then these are the stocks that I have. I just chose them randomly, really, but you can definitely edit the list and add your own stock ticker name. And this is just code to make screen switching very easy. So like that canvas example, this is initially creating a canvas object just to interact with later and to update. Then we get to the setup function. Setup function runs once, and like its name, it's going to include everything that you want to set up for the rest of the program. That's going to include connecting to Wi-Fi, setting screen rotation, and confirming that the Wi-Fi is connected, and outputting like anything that confirms that, hey, this thing is ready to go, run like the actual code. So this is the API access function. It's for that Ron Swanson quote generator, but initially I'm creating a canvas, setting the text size, creating an HTTP object that's going to go to this URL. This is the HTTP Ron Swanson quotes URL, and then it's going to do a GET request on it, grab the string, parse it, put it into this quotes variable, and then I'm going to printf to the canvas, push that change to the canvas, and here is just some code to deal with errors and to free up the resources. Keep in mind you are working on microcontroller, so use your onboard memory very efficiently. If you've taken 311 or so, you'll learn that lesson with that first project, with one of the projects there, where memory usage can be very, very hard to control. And this is for the Jeopardy code. Jeopardy API has a lot more things you're importing. So this part of the code is the same. Again, you're setting up a canvas, setting up text size, submitting a GET request to this URL. But there's a lot more data you're importing. So string, the answer, for a string for the question. Then you're outputting that to the serial console, as well as printing F to the canvas. One sec. Alright, I'm back. I had to do something real quick. But yeah, it's getting that title and category and parsing that data purely on the device itself and then displaying it. So this is the code for actual screen switching and accessing the buttons. So it's going to say, hey, if this button's been pressed, update the screen until it reaches maximum numbers of screens, then set it back to 0. If the other button is pressed, subtract the screen, change the screen again, and if it's less than 0, send it back to the maximum. That'll have that rolling effect. Then you can print the current screen. That's just for debugging. And this is a switch statement that'll handle which screen or which API is displaying currently. I didn't show the code for all of these because some of them include my API keys, and I don't really want to share that publicly. And a lot of it's just repeated code. If you understand what's going on here, you should be able to access the other APIs as well. Here is just a little bit of extra code at the bottom where this works in a loop function. So if you don't have something to mitigate like how many times a loop is going to run, you're gonna it'll try to run that loop as fast as possible. So I was querying data from all these APIs as fast as it could, multiple times a second, and that is how you get banned from using an API, like how you get your IP blocked from an API itself. So you want to include some code in there that slows down your API requests. And this just works out for least. If all the buttons are released, just go into a delay. And so right here is a video of the final product, where initially it's at the joke screen, It got that live. Then it switched to weather, which again, it got that live in the background. That's the Jeopardy screen. And Ron Swanson quote. Then that's the live stock data. Each time you go to the screen, it's updated and gets the data as fast as it can. And yeah, that's essentially how that part works. Just to show you how some of these APIs look in terms of like actual usage. Close out there. Are you all able to see this, or did I just share the? Yeah, okay. I think you're able to see it. Cool. So that's the, as I said, here's the HTTP link itself. So if we actually go to this, that's what it looks like. So this is that JSON object right here. It's just not spaced out as it should be, but here's an answer, here's the question and everything. That's what this code is taking and turning it into usable strings, usable data types. So, any questions? That was a lot, I know, but this is kind of like a quick crash course intro to it.
Can you hear me?
Yes, I can. You're a little low, but yes.
So basically, like, are these sort of like devices like designed like hardware that can run like a single or designed to like run a single program over and over again?
Yes. Most microcontrollers are built like that. They're supposed to be like low power and low resource wise. So let's go back to this picture right here. You can't tell how big this is, but this is like about the size of like 2 of your fingers, and it's also meant to be very cheap as well. There's microcontrollers that aren't, but when it's that low power and meant to be that like efficient, it can be rough to have to run a full-on operating system. These don't have operating systems. They have firmware, which just loads up your code and just runs your code. Yeah. So it usually just runs one program at a time. You can't really have multiple things. You can make that program as complicated as you'd like if you wanted to include threading, or if you wanted to include all these extra processes in there. But at the end of the day, it would be just one program.
Could you like make one of those rotating signs, like signs with the LED lights that sort of like simulate text and like change? Could you like make one of those using one of these?
Very easily, yeah. You're talking about you're talking about an LED matrix display. So these are simple LED matrix displays, and yeah, one of these signs right here, you would just need to download the relevant Arduino library, or just look at how they function at the low end. But you'd be very easily able to make one of these rotating signs. I think I've made a very simple one using a what's called a 1604 display. These are very popular. And you could make a rotating sign out of that very easily if you're working on that project.
We experimented on these in our own time. Could we like put that on our resume? Does that make sense?
Sure, yeah. One of the things about this is that it makes amazing resume builder projects. The soft skills you're kind of learning from looking at the documentation, writing your own code like this is very in demand at like any company you'd go to, because no company is going to have you write completely construct your own code from the start. So being able to take something like this, read the documentation, and make and sort of find your own functionality through that is a very important skill, and definitely worthy of a resume. I have an ESP32. I have just ability to use ESP32 on my resume right now.
Do you mind showing us what display you used for this project again?
So I didn't use like a separate display. I used this thing called M5Paper. it's an ESP32 board in there, and they just added a bunch of extra peripherals for you to have like an onboard display, have an onboard button and such. But it's called M5Paper. It's one package with an ESP32 built in.
Oh, okay. Thanks.
Mm-hmm. Any other questions? Now let me actually scroll up in chat to see. Okay, cool. Before y'all go, I did want to share this. This Friday at 11 a.m. for Engineers Week. Also, it's Engineers Week. I should have started with that. But we're going to have a Arduino workshop. It's in ITE 238. That little QR code, you can use that to sign up for it. Because of COVID, there are maximum people we can have within the room. But the way the workshop works is you go in there, I give like a small little intro to the Arduino platform, and you're given a bunch of peripherals, a bunch of like tutorials you can follow to make your own, to follow a project or make your own. If you wanna, we'll have some of those displays that I was talking about, the LCD displays on there. So if you wanna try prototype that project, you're welcome to. It's like 2 hours, but most of it's you just making anything you want. It's open to everyone, whether you're in IEEE or not. So yeah, that was about it. And this is all the resources I used. Thanks for coming.